Hello girls, I hope you're staying safe at home. To continue with organic chemistry, today I'm going to talk about alkanes. Now by now you know alkanes are hydrocarbon in which all the link between carbon and carbon is satisfied by a single bond. So therefore they are known as saturated hydrocarbons because all the four valencies of carbon are satisfied by the formula CnH2n plus 2. Okay, so between two carbon bonds there is a single covalent bond, and even between hydrogen attached all around there is a single covalent bond. Okay, now when we talk about the homologous series of alkanes, you can see that it starts with methane, one carbon and satisfied by single covalent bond. Moving on to ethane, two carbon atoms, again satisfied by single covalent bond all around. Similarly, next we move on to 3 carbon, that means it is propane. Again you can see only single bond all around. Then we have the isomers of butane. One, we have the normal butane, linear and a single bond all around. Okay, then you have the branched butane. Okay, we'll come back when we do isomers. Okay, when we talk about the isomers of butane, we'll come back here again and I will talk about in detail. So here this is you can see a branch structure. So this is also butane, and then finally we have pentane. Pent means 5 carbon, and all around carbon you'll see it is satisfied by a single covalent bond. Okay, now moving on to the properties of alkanes. Now all alkanes, when I talked about the homologous series of alkanes, I'm talking about methane, ethane, propane, butane, pentane. Okay, they all have common properties. Okay, all alkanes are flammable. Flammable means they can easily enter into a combustion reaction with oxygen. Okay, with oxygen to form carbon dioxide and water. I'm talking about hydrocarbons. Okay, then methane is the main component of natural gas, and butane. Okay, you find methane as the main component of, I said, natural gas, and butane you find in the common lighter fluid. If you have seen the lighter, okay, inside that you see liquid. What is that? That is butane that you see. Okay, so these hydrocarbons are very unreactive under ordinary conditions, so they are also known as paraffins. Para means little, comes from the word parum, P-A-R-U-M, which means little. Okay, and affin, of course, means affinity. Okay, less reaction, it hardly reacts. Okay, now next we move on to the sources of alkanes. The main source of alkanes are natural gas and petroleum. Natural gas contains mainly methane with very less amounts of ethane, propane and butane. Okay, now isomerism in alkanes. Alkanes with more than 3 carbon atoms show isomerism. Okay, the various isomers differ in the framework of the carbon chains, therefore they show chain isomerism. So that time, remember, I had said I'll come up when I talk about the isomers. So these two are the isomers of butane. Butane, you know, has 4 carbon atoms. 4 carbon atoms. These 4 carbon atoms can be arranged in 2 ways. Therefore, there are 2 isomers of butane. Now, this one is known as N-butane. Okay, N means normal. This is normal butane. Okay, and next is which shows branch structure. This one is linear structure. All the carbon are in a straight line, as you can see here. Okay, and here you can see 3 carbon are in a straight line, and then there is a branch coming out. So this is branch structure. So this is known as isobutane. Okay, and of course you know IUPAC name 1, 2, 3. So this is CH3 because 1 carbon and 3. So this is methyl group. So what will the IUPAC name be? 2-methyl, if you remember, propane. Okay, so these are the 2 isomers of butane. Okay, now moving on to isomers of pentane. Pent means 5 carbon atoms. Okay, so they can be arranged in 3 different ways. Okay, first is N-pentane, the normal, when the carbon are in a straight line. So this is N-pentane. Because pent, you know, 5, so we take 1, 2, 3, 4, 5 carbon atoms in a straight line, and then the hydrogen are all around it. Okay, now next is here again 1, 2, 3, 4. What is the IUPAC name? 2-methyl butane. Why butane? Because there are 1, 2, 3, 4. Okay, but if you see the molecular formula, it is C5H12 only. But here, why but? Here we are taking only 4 here, and the methyl group is added here. So the common name for 2-methyl butane is isopentane. Now moving on to the third isomer of pentane. Okay, here it is arranged this way. So 3 carbon atoms, 1, 2, 3, linked in a linear chain. Okay, and 2 methyl groups attached here. So IUPAC name will be 2, 2 dimethyl, 3 carbon atoms you can see, so propane. Okay, and the common name is neopentane. Now moving on to the occurrence of methane and ethane. Now methane is also known as marsh gas. Why? Because it is formed at the bottom of marshes by the fermentation of cellulose. Okay, and this fermentation is done by some special bacteria. And you will also find methane in air exhaled by animals whose food contains cellulose. You know, cellulose makes up the cell wall of plants. So herbivorous animals, when they exhale out air, what does it contain? Little bit of methane. Okay, and it is also found in intestinal gases and in the blood of animals and humans. And their cavities in coal contain 90% of methane, which is also known as fire damp. And you can also obtain methane by dry distillation of wood and peat. Peat is coal. Okay, and we were talking about the occurrence of methane and ethane, but till now you must be thinking, Miss told only about methane. She did not tell us about ethane. So remember, ethane is always found to the extent of 10 to 20% along with methane. So wherever there is methane, you will always find 10 to 20% of ethane with it. Okay. Now you know methane is also known as the greenhouse gas. Okay, since it is the main constituent of natural gas, it absorbs the outgoing heat radiation from the earth, so it contributes to the greenhouse effect and it is a greenhouse gas. Methane, you know, it remains in the atmosphere for about 10 years and it is about 20 times more effective in trapping heat when you compare it to carbon dioxide. Okay. Now, methane is also a very important energy source. So efforts to prevent or utilize methane emissions can provide significant economical and environmental benefits. Now, moving on to the structure of methane, you will see that the methane structure is three-dimensional. Okay, the four outer electrons in the carbon atom, we're talking about the electrons. Okay, 4 electrons in the carbon atom move very far apart from each other because electrons, they are negatively charged, so they repel each other. So it is a fact that the electrons will have greatest distance between themselves when the carbon-hydrogen bonds are in the shape of a tetrahedron. Tetra means 4. It is pyramid shape. So what is this shape? It is tetrahedron. Okay, that is in the shape of a pyramid. Okay, you know the electron dot formula. Carbon has, and it shares 1 electron each of hydrogen all around. Hydrogen has only 1 electron, so this is the electron dot formula. And when we move on to the structural formula, this is the structural formula, a single bond and attached to hydrogen. Okay, so this is all for today, children. Please go through your textbooks and see whether you've understood the explanation or not. If not, if you have any questions, feel free to WhatsApp me. Have a great day, children. Stay safe at home. God bless you.